Okay, so we're going to do a lab for Newton's second law, which is force equals mass times acceleration. And what we're going to do is we're going to use these cubes to set up a ramp and roll these different spheres down and see how far it can push this cup. Alright, so we're going to start out with ball 1, which we have the bouncy ball. Now we're going to do just one cube high. Okay, so just one cube high, and we're going to make a ramp like that. I'm going to move it over here, and we're going to set the cup down right on the edge of the ruler, and then we're going to roll the ball down. Okay, so now I need to take my other ruler, and I'm going to measure in centimeters. And I'm going to measure how far the cup went, which is 4.2 centimeters. So I'm going to take my sheet and I'm going to record for ball 1 4.2 centimeters. Okay, now I'm going to do the same thing for ball 2. Set up my ramp. Cup. Take ball 2, which is a plastic golf ball, and measure. .6 centimeters. Okay, so I'm going to write down 1.6 centimeters. And now we're going to do the same thing with ball 3, which is a glass marble. And we'll measure. .1 centimeters. So after part 1, we already weighed the balls. So we had 13 grams for the bouncy ball, 4.2 grams for the golf ball, and 18.2 grams for the marble. And with one block high, we found that ball 1 went 4.2 centimeters, ball 2 1.6, and ball 3 12.1. Now what we're going to do is see the acceleration change. So we're going to take ball 1, which is the bouncy ball, and we're going to do one block again. Okay, and measure. 4.3. Now we're going to make our ramp 2 blocks high. So I stacked my blocks up 2 blocks high. And now we're going to do ball 1 again. Okay. Measure. You can see with the higher ramp it went further this time. 7.5 centimeters. And now we're going to do it one more time. We're going to make our ramp 3 blocks high. Right now you should be able to make a guess as to what you think is going to happen. It's going to go further or stay the same. Go to measure. 12.1. So you can see with the different heights, 1 cube, 2 cubes, 3 cubes, we got a lot greater distance on our cup. So now we're going to do ball 2 same way. We're going to go back down to 1. measure. 1.8. I'm going to do 2. $3.8 and 3 blocks. $5.4. Now if we look at the first 2 balls, you can see that ball 2 didn't go near as far as ball 1 did. So now we can try ball 3. With 1 block. That one went 12.7. So that one's already gone farther than any of our other balls did. That was just 1 block high. 2 blocks. That went quite a ways. Zoom out here. Still get it with my... I want to go this way. So I want to get the closest part of the cup. Right at 25 centimeters. And 3 blocks. Make sure I have enough room on my table. Here's 3 blocks with the glass marble. Alright. You can see that one went quite a ways. It's longer than my ruler, so I'm going to get my meter stick out here so I can measure the distance. $35.4. Alright. Take my ramp down. Alright. So you can see here, ball 3, the marble, went the furthest by a long ways. So let's take a look now at the questions we need. Question 1 says, how does the mass of an object affect its force? So the more mass we have, you can see the marble had the most mass, and then the bouncy ball, and then the golf ball. So the more mass we had, how did that affect the amount of force that we had pushing on that cup? Go ahead and pause and think about it for a second. Okay, so the marble had the most mass, and the most force sent that marble going the farthest. So the more mass an object has, the greater the force. Alright, number 2 says, does the sphere that has more volume have more force? Well, if we take a look at the three spheres that we had, the golf ball has the most volume. It takes up the most space. So, if we look at our data, does the golf ball, which was ball 2, did that have the most force? No, but if we look at 2, it was also our lightest. So, does the sphere that has the more volume have more force? No. The sphere with more volume had less mass and less force. Okay. Question 3 says, how does acceleration of an object affect its force? Well, the acceleration changes was the amount of cubes we used. And with 1 cube to 2 cubes to 3 cubes, we went up each time. So we could say the more acceleration an object has, the more force it will have. And the last question, what did you learn from the investigation about mass and acceleration? Well, we said up here the more mass an object has, the greater the force. And we said the more acceleration an object has, the more force it'll have. So, the more mass and acceleration an object has, the greater the force will be. Now, if we think about that and we look at Newton's law says force equals mass times acceleration. So if we have a bigger mass and we have a bigger acceleration, our force is going to be bigger. So that was our lab from Newton's second law. Hopefully it helped you put Newton's second law into some perspective on how it's actually used.